All right, so today we're covering lesson 4.8, and we're going to talk about two theorems, the remainder theorem and the factor theorem. Really, instead of giving you two different theorems that you would memorize, we're just going to actually show how these work in actual problems, and both of them involve the use of synthetic division. So let's start off with what it means to do something called synthetic substitution, and that's going to lead us into what really is the remainder theorem. Okay, so in the old days, when we evaluated a function, when we were asked to find f of -3 in this case, you don't have to write this down, but to evaluate f of -3, we're used to doing this. We would replace the x's with -3, and maybe go to our calculator and let the calculator crank out this answer. Remember that? So the input -3 produced that output if we went to our calculator and did the math. Well, there's another way of coming up with that output, and it involves synthetic division, and it works like this. I'm going to use the -3 input in the house, like we did a few lessons ago. And just like normal synthetic division, I'm going to write the coefficients and the constant off to the side, making sure that I don't skip over any exponents. They go in order. They start at 3, then I go 2, and then 1, and then constant. So I don't have to plug in any filler zeros. And then here goes synthetic division. I bring down the first number always to start, and then the number below the line multiplies times the number in the house, and 3 times -3 is -9. Synthetic division always involves addition, so this is -15. Multiply, -15 times -3 is 45, and you add 46. Now we need to multiply 46 times -3, -138. And we add those together and we get -149. So here's the remainder theorem. Instead of just memorizing it, here's what it says. This input, when I use synthetic division, if I did do the old-fashioned way of inputting -3 into all the x's and then do the math, I would get that output. So the remainder, using synthetic division, is the output, using the old-fashioned plug and chug. Okay? So that's basically what you're going to be doing on problems 8 through 15. I want you to show synthetic division instead of what you're used to doing of actually inputting the number in for the variable and then simplifying from there. So let's go ahead and do f of 2 with this same function. You're going to have two answers. Notice that unlike synthetic division, let me just make this point. With what we're used to doing with synthetic division is we're given a binomial that we're dividing by. And we always had to be careful that we use the opposite of that number in the house. Remember that? That was a key point. Well, in this case, you're actually given the number that would cause this to be 0. You don't have to change the sign. You just take the literal number that is given as the input, and that number goes in the house. So you don't have to worry about changing any signs here. Okay, so I think we could probably get by on doing just letter A, and then we'll move on. But let's go ahead and finish it. Let's do the f of 2 example. So this time 2 is going in the house. And I go through synthetic division again. So bring down the 3, multiply, add, multiply, add, multiply, add. So f of 2, let me just go ahead and finalize the answer. up here we said f of negative 3 is negative 149. F of 2 is negative 9. So going forward, if especially when you run into classes in the future, there's some, like UT, college algebra doesn't allow you to use calculator at all. So instead of going through this, maybe synthetic division would be an easier way to come up with points on a graph. Using synthetic division is pretty nice. So in other words, we'll make another connection. The point negative 3, negative 149 is on the graph of this cubic polynomial. Okay, any questions so far? We're going to skip letter B if that's okay. It's just more of the same. You're going to do synthetic division twice. Just be careful. Looks like on letter B you would have to fill in a 0 for the quartic. You'd have to do a 0x to the 4th. So remember that. That's an important thing to keep in mind when you're doing synthetic division. You'd also have to do a 0x because you skipped over x to the 1st. All right, so let's move on to the factor theorem. What does the factor theorem say? Well, we can also use synthetic division to come up with all of the factors of a particular polynomial. Factors just means what are the binomials and or trinomials that would multiply together to give us this. Well, they're going to give you one of those factors. It's our job to find the other two. And we're going to use synthetic division to get those factors. So this time, think of dividing by x minus 1. So remember, when I'm dividing by a binomial that's given, I need to be careful that I change to the opposite of the way it looks. So I'm going to put positive 1 in the house. And I write 1, negative 6, 11, negative 6. Now, if this truly is a factor, then when I go through the synthetic division process, I should get a 0 remainder. Let's see if that's true. So bring down the 1, multiply, and add, multiply, add, multiply, add. Yes, x minus 1 is a factor because when I used it in synthetic division, I got a 0 remainder. We already knew that because we were told that it is. What we need is this. If I divide it into a cubic polynomial, which I did, then this should represent a quadratic trinomial. All right, it actually represents 1x squared minus 5x plus 6. Remember that? This is just a repeat of what we learned with synthetic division. So to go along with x minus 1, there are two more factors out there, and when I factor this, I will find those other two factors. So I'm going to come up here and let's see, are there two linear binomials that would multiply together to give me this? Are there factors of positive 6 that add up to negative 5? Yep. All right, so negative 2 and negative 3. So what would the factoring of this be? What would it look like? All right, so that would be my final answer. The directions are find the remaining factors. They gave us this one, and we found the other two. But it all starts with take the factor that you're given and use synthetic division, and then you can find the other factors. Any questions about that? All right, let's try letter B. Same type of deal. I'm going to put positive 1 in the house. 3, 10, negative 1, negative 12. Now, if we don't get 0 as a remainder, when I do this, when I put the one that I'm given using synthetic division, if I don't get 0 here, then something's wrong. You need to go back and check your work. Well, let's see what we get. 3, that would be 13. 13, that would be 12. 12, 0. All right, we're in good shape. it's not really the fact that we got 0. That is important, but when I do realize that I get 0 as a remainder, it's these numbers that I need to come up with the other two factors, because these numbers represent 3x squared plus 13x plus 12. And now I got to come up with a way to factor this. So if you want to, you can do trial and error if you like, or you could rely on the box method. Box method comes in handy in cases like this. 3x squared, 12, that's 36x squared. So I need the factors of 36x squared that add up to 13x. That would be 9x and 4x. And now I find the GCFs of both rows and both columns. So going this way, this row, the GCF would be 3x. And going this way, it would be 4. So there's a factor, 3x plus 4. Plus 4. And then going this way, this first column, the GCF would be x. And going this way, it would be 3. And so to go along with the given factor x minus 1, we found the other two. So this is really my answer, final answer. These two factors, 3x plus 4 and x plus 3. Do you have any questions so far? So let's try one. These were both dividing into cubic polynomials. Let's see what it looks like when we divide into fourth degree or quartic. It's a little more involved. You're going to be given two factors. We have to find the other two. Notice it's fourth degree, so there should be a total of 4 factors involved. And it really doesn't matter which one of these you start with in synthetic division. Just pick one. You'll get the same answer either way. You could let -3 go first in the house, or you could go with -1. Doesn't matter. I'm going to go with -3. 2, -3, -33, -13, and +15. All right, and going through synthetic division, bring down the 2, multiply, add, multiply, add, multiply, add, and good feeling, yes, we got 0. So the problem here is I divided into fourth degree. This represents a third degree polynomial. So I don't really have a good way to factor this easily. I think it's easier just to go ahead and jump into synthetic division again using the other factor. All right, so this time I'm going to put -1 in the house, and I'm going to use these numbers, the result of my first division. And so let's go through synthetic division. I divided into cubic, so this time it should be quadratic. Those are nice and easy to factor. So bring down the 2, -11, +11, 5, -5, 0. All right, so these numbers represent the following quadratic equation. And we don't really need equal 0 since we're not solving. All we have to do is come up with the factoring of this, and we'll have our answer. All right. Do we need to finish that, or do you think you guys can handle factoring this? This is just basic, I guess, algebra 1. Anybody go ahead and get the factoring? You got it, Alex? What you got?
X minus 5 times 2x minus 1.
Okay. Good job. Did you use the box method? All right. And it's probably what I would have done. He just saved us a little bit of time going through it. Any questions on how he did that? Yeah? Uh-huh. Okay. Now it should, because it shouldn't matter which one you start with. So did you get 0 remainder? Yeah, so there's something in your arithmetic and you put -1 in the house. Let me just run through that real fast. Let's see if we can see what happened. Yeah, if you didn't get a 0 remainder with what's given, you know something's wrong. You did something wrong with your math. I would double check the signs of, the polynomial. Make sure they're all right. Okay, so bring down the 2 and multiply. That's -2, which is -5. And that's -28. 28 and 15. Yeah. Okay, question? Yeah. Well, the way this is set up with minus in front of plus, the factoring has to contain both minuses. So in cases like this, I know what the signs should look like. I don't even use signs in the box because they've got to be both minus. Okay, anyone else? Good so far? Pretty easy? Okay, what I'm going to do, number 29 is actually one of your homework problems. What I thought I would do is, I don't want to work all the way through it, but I want to get you going, because this time they do provide a function, here it is, and then they give you the graph. So the only difference here is, instead of providing the function and actually telling you what 2 or 1 of the factors are, you have to take a look at the graph and tell what the factors are. Remember, to be a factor, it has to make the function equal to 0. Well, there are 2 numbers that I could plug in for x and make it equal to 0. What are those 2 numbers? -2 and 3. So you can think of it this way. One of the factors, if I'm making 0, one of the factors would be x minus 3. Okay, if I put 3 in for x here, would I get 0? Yes. So think of x minus 3 as being one of your factors, and then the other factor in linear binomial form would be x plus 2. Okay, does that make sense? So now you're back to pretty much the same type of thing you did here. Now it's like you were given 2 of the factors, and now you're going to go through synthetic division twice. And it really doesn't matter which one you start with. My illustration here is I've started with 3, and I'm going to go through synthetic division, get a result. Then I'll go through synthetic division again with -2, and then you'll want to factor that result. So if I'm saying something that you don't understand, tell me. You think you got it? Yeah.
So whenever you actually plug it in to solve, you just do what it says in the graph pretty much?
When you're looking for the numbers that go in the house, yeah, you're looking for x-intercepts. Yeah. Well, since they want your answers to be factors, this will actually be 2 of the factors. And then you're going to come up with the other 2 after you've finished. It'll look like this when you're finished factoring the second time through synthetic division. Let me double check the instructions. Yeah, the instructions on number 29 and 30 are use the graph to find all of the factors. Well, here's 2 of them. You just need to give me the other 2. So your answer here is going to be 4 different factors. Yeah.
Is it possible that you get down to your quadratic function and it's not factorable?
Yeah, that is possible. And so if it's unfactorable, then if it's a trinomial, which it will be, then that is a factor. So in that case, you would just have 3. Good question. Okay, anyone else? You think you got it? Yeah.
I work, and the one that we get doesn't equal the one that you get by doing FOIL with x minus 3 and x plus 2.
Okay, so you want to let's just go ahead and work this one. Are you working this one out? All right, so let's just see what happens. We bring down the 1, and we got 1, 3, and 2, 6, and 8, 24, and 0. All right, so now I'm going to use synthetic division again with -2 with these numbers. And I should get 0 again. Okay. Well, let's see, -2, -1, that's 2, that should be 4, -8, and 0. Okay, and what's left is a quadratic, and I guess this is what you were referring to. This is a quadratic that can't be factored, which tells me that if you can't factor this quadratic trinomial, then this ends up being one of your factors to go along with. Now we're going to have 4 different solutions, but it looks like 2 of them are obviously real. What would the other 2 be? So what would we call them if they're not real? Yeah, they're going to be complex. So if this doesn't if it did factor, then we would have 4 x-intercepts. We'd be crossing the x-axis 4 times. So we do have 4 solutions, 4 roots. It's just that 2 of them are real and 2 of them are complex.
That's not because with the 4 one, it's x squared minus x minus 6.
For the which one?
For x minus 3 and x plus 2. If you boil it, you put 10 off. So maybe I guess it's at the bottom with the curve.
I don't either. I don't know what you're asking. Yeah, the bottom line is, to go back to Corey's question, if you get down to this quadratic trinomial and it doesn't factor, then this ends up being a factor itself. It's prime. Yeah. Your actual answer will be these 3, x minus 3, x plus 2, and this one. Mm-hmm. Yeah, somewhere. I mean, you don't have to rewrite them if you just want to, circle them. It's fine. Any questions? So basically, you're going to do number 30. I did number 29. And so go back and look at number 29 when you get to number 30. And this is the last one. I wanted to do one of these. These are kind of fun. This time, this really helps you understand synthetic division inside and out, because we're going to use synthetic division to find out what this coefficient here is, this labeled K. So let me walk you through this example so that you can do the other 3 like it. So I'm going to put +2 in the house. I'm going to put 1, obviously, for now, I'm just calling this K because I don't really know what that number is. It's my job to find out what it is. What I do know is, according to the instructions, the remainder should be 3. Okay, and that's going to be true for all these problems in this set. You know the remainder is 3. Well, according to synthetic division, I know that I'm supposed to bring down the 1. I know that if the remainder is 3, what must this be if I'm adding? That must be 20. Okay. I know that synthetic division means there's a number here times the house number that gives me this. So what must this number be? 10? Yep. This is 10. So if, what must K be? Well, let's see, where are we? Oh, I'm multiplying the number under the line. 1 times 2 is 2. And so I can kind of back my way into what K should be. So what is K? Yeah. You see how that works? So knowing what the remainder is and knowing that you can bring this first number down, and then you're kind of working your way toward the missing coefficient from either side. All right? Do you have any questions? You ready to start? Okay. I'll let you get going on the assignment, and let me know if you have any questions.